Hello friends, welcome to Shiksharthi. In this session, we are going to discuss exponential functions. So let's start. Now when we say exponential functions, we mean to say a to the power x. So here the function is fx is equal to a to the power x. So as always, the prerequisite for this session is you should have the entire knowledge about the functions. Now when I say the entire knowledge about functions, in that case you should know how to find out the domain, how to find out the range of the function, how to use domain and range to plot, and thereafter you should know how to draw the graph. Okay, so now when we say that the function is a to the power x, in the very first place let us try and talk about the domain of fx. So when we are talking about domain of fx, we shall be adopting the maturer approach to find out the domain of fx. Now when we say that we are going to adopt a maturer approach, what I mean to say here is we would not be taking those 7 set of values. We'll be taking a maturer approach like f of minus x, f of 0 and f of plus x. But even before that, let us talk about some domain constraints on the constant value of the function, because when we say a to the power x, in that case a is a constant term and x is a variable term. So the conditions on the constant terms are a should be greater than 0, and along with this a should not be equal to 1. In other sense, a cannot, a function of the sort a to the power x, which is known as an exponential function, is not defined for negative values of a. Second, if I say 1 to the power x, it becomes a meaningless function, because 1 to the power x in any case, irrespective of the value of x, is going to be 1. Now let us talk about the restrictions or the input on the input values of the variable. What is f of minus x here? F of minus x would be a to the power minus x, which is equal to 1 divided by a to the power x. So can we say that now once we know that a is positive, so this answer will always be positive. Analogously, if I want to calculate f of 0, this will be nothing but a to the power 0. Now a to the power 0, given that a is positive, a is a non-zero term, it is then only that we say that it is equal to a 1. Please remember 0 to the power 0 is an indeterminate function. So a constant term which is a non-zero constant term raised to the power 0 will only be equal to 1. Third, f of plus x will be a to the power plus x, which in any case the answer of which will always be positive. Now let us try and understand this part. Which part are we talking about? When we say that this answer is going to be positive, let us try and understand these two parts, and thereafter we would draw the graphs. Okay, now when we are trying to understand these two parts, let us give some values to a. So let us say in one case, if let's say I'm saying that a is equal to 1 by 2, then what will be f of minus x? In that case, f of minus x would be nothing but, so if I substitute the value of a as 1 by 2, so f of minus x will be nothing but 2 to the power x, which in any case now you know that you are supposed to input negative values only. So once you keep on inputting the negative values of x, the answer here will always be positive. For example, if you input x is equal to minus 1, the answer will be, what would be the answer? The answer would be 1 by 2. Okay. Now, what will be the value of f of 0 when a is equal? So this will be nothing but half to the power 0, which is equal to 1. And last but not the least, when we are talking about f of plus x, this will be nothing but 1 upon 2 to the power x, which also we know that we are supposed to input only positive values of x. So the answer will always be positive. Last but not the least, let us assign a different value to a, and in this case we are going to take if a is an improper fraction. In the first case, we had taken the value of a as a proper fraction. So now, when we are calculating f of minus x, this will be nothing but 2 to the power minus x, which eventually will be written as 1 divided by 2 to the power x, and you can borrow the result from here, which is the answer will always be positive. What will be f of 0 here? F of 0 will be nothing but 2 to the power 0, which will be equal to 1 as discussed earlier. And last but not the least, when we are calculating the value of f of plus x, this will be nothing but 2 to the power plus x. And now you know that you are supposed to input only the positive values. So whichever positive value of x you would input, the answer will always be positive. So what is the learning from here? The learning from here is, the learning from here is, we are talking about the domain of the function. So the domain of the function d will be nothing but a greater than 0, union a cannot be equal to 1, union x would be any real number, because you can input any negative value, you can input any positive value, at the same time you can input the neutral value. So what is the range? The range is y is greater than or equal to 0? No, it is only y is greater than 0 is the range. This is the point to be understood, after which we can plot the graph. So now you should know how to plot the graphs, and incidentally we would take the two examples that we had taken while plotting the graphs. So one is, we would draw the graph of 2 to the power x, and the next graph that we would draw here is half to the power x. You know how to draw the graph, but here we will be adopting a maturer approach, which says we'll take three values: x is equal to 0, x is equal to minus 1, and x is equal to plus 1. These are three values that we are going to take for both the graphs. So now when we are plotting the graphs, what is here now? So here we are plotting the graph of, let us say here we are plotting the graph fx is equal to 2 to the power x. Here we are plotting the graph of fx is equal to 1 divided by 2 to the power x. And just to mention the range, this is 2, this is 1 plus 1, this is plus 1, this is plus 2. So plus 1 plus 2. Okay. Now when we input x is equal to minus 1 in this graph, How much is 2 to the power minus 1? So we'll get it as half. So let's say we are getting half here. This is half. Okay. Then we know that 2 to the power 0 is equal to 1. So we would, and then we know that when we put x is equal to 1, in that case 2 to the power 1 is equal to 2. So we need to join these 3 points with the help of a relevant graph. Now before we talk about the relevant graph here, let us complete this plotting for the second graph also that we are expected to draw. So in this case, when we put x is equal to minus 1, we get the value as, we get the answer as 2. When we put x is equal to 0, we get the answer as 1. When we put x is equal to 1, we get the answer as plus half. So let's put this value as plus half. Let's put this value also as plus half. So once we have done this, now we can join these points, keeping in mind that an exponential function is a non-linear graph. Now non-linear graph means that this would be a curve which either opens upwards or it opens downwards. A curve that either opens upwards or a curve which either opens downwards is the curve that you are supposed to draw. In this case, we will have a curve which opens upwards because the values are progressive and the graph moves upwards. This is the best way to understand with the limited knowledge that we have at this stage. And the same thing we would say here. We would have a curve which goes down but opens upwards. Please remember, in both the diagrams, in both the graphs, the red colored line will never ever touch or intersect with the real x-axis. Why will it not intersect with the real x-axis? It will not intersect with the real x-axis because we know that x-axis is y is equal to 0, the line y is equal to 0, and we know that the range does not have y is equal to 0. But the graph would definitely intersect with the real y-axis because x is equal to 0 is a part of its domain. I hope you'll be able to learn a lot from this comprehensive discussion that we have done here so that you can take your learnings to the next level.